Hi everybody, hope you had a good weekend. Hope everybody's safe and healthy today. I'm going to run through the pre-test with you. I got to keep an eye on my time. The videos keep getting cut off. So I'm going to go ahead and start with the pre-test. So if you have any questions about anything on the pre-test, I'm going to go through the problems right in order so you can look those up on the video here and get your questions answered, hopefully. Okay, so number one, we got cosine x equals -2/7. And we got to find the other functions, and we are told that we are between pi and 3 pi over 2. This is important because that tells us where we're going to draw our picture. We're going to draw our picture right here in quadrant 3 because pi, that's 180 to 270. That puts us in quadrant 3. We know the cosine is -2/7. I'll do my Pythagorean theorem. 2 squared plus x squared equals 7 squared. So x squared equals 49 minus 4. X squared equals 45. This looks like the square root of 45, which is 3 root 5. And that would have to be negative because I am sitting in quadrant 3. Okay, so here we go. I need the other functions, so I'm going to need sine, I'm going to need cosecant, I'm going to need tangent, cotangent, and of course secant, I'm just going to squeeze in right here. Secant is -7/2, so that's a no-brainer, the reciprocal of the cosine. The sine will be -3 root 5 over 7, and the cosecant then will be 7 over -3 root 5, which we will rationalize by multiplying top and bottom by root 5, and we get 7 root 5 over -15. Tangent is -3 root 5 over -2, so that's just going to be 3 root 5 over 2, and the cotangent then will be 2 over 3 root 5, which we will rationalize, multiply top and bottom by root 5, and get 2 root 5 over 15. We want to evaluate the secant of 11 pi over 7 and the angle whose tangent is -2/3. I'm doing this on my calculator. Notice there's a little star by the problem. So I'm doing it on my calculator. To type a secant in on my calculator, I will literally type 1 divided by cosine. So 1 divided by cosine, 11 pi divided by 7. By the way, this is a radian measure, so my calculator is set in radians. And I got 4.49. There's no rounding instructions given, so I'm just going to make them up. 4.494. Excuse me. The angle whose tangent is -2/3. Second tangent, -2/3. I'm just typing it straight in. It says -0.588. That would be in radians. If the directions stipulate degrees, then we'll type in exactly the same thing, but in degrees, it would be -33.69 degrees. Again, if the directions don't say, then do whatever you want. If the directions indicated radians, we'd have our calculator in radians and get this answer. If it says degrees, we'll have our calculator in degrees and get this answer. Now we're going to do a sketch. And we are going to sketch a sine curve. So the first thing I want to do is make sure if there is a coefficient on x, it is factored out. There is one, and it is factored out, so we are all set. So here we go, and I'm going to list my amplitude, my period, my frequency, my phase shift, and my vertical shift. Okay, so this is a sine curve, positive sine curve. Phase shift is pi over 4, so I am beginning my graph at pi over 4. So I've got a handy dandy sine curve. Just a regular old sine curve with an amplitude of 2. Remember, this tells me my amplitude. Now, how long is this curve? What is its period? Well, the normal period is 2 pi, but this one has been divided by 2, so its period is pi, and its frequency then is 1 over pi. Now, that means that from here to here is pi. So to find this label, I'm going to have to start at pi over 4 and add pi to that. So 1/4 and 1 is 1 1/4, or 5/4. Right here in the middle would be the midpoint of 1 and 5. That is the average of 1 and 5. 1 and 5 makes 6, and half of that's 3. Ditto again. 1 and 3 is 4, and half of that's 2. And one more time. 3 and 5 is 8, and half of that is 4. This curve has no vertical shift. There's no number, plus or minus, added on the end. If there were, I would simply take this picture and move it up or down that many units. Done. Good. Find the exact value of the tangent of 2 pi over 3. Well, probably we'll change 2 pi over 3 into degrees. So 180 divided by 3 is 60, times 2 is 120. So I'm going to find the tangent of 120. Exact means no calculator. So here's 120. This angle then would be 60 because this is 180, this is 90, this is 120. So I'm 60 degrees away from 180. This would be root 3, 1 and 2, and the 1 would be negative because we are going left. We are going into quadrant 2. Tangent, y over x. So my tangent is root 3 over negative 1, or negative root 3. Perfect. Now, we talked about this last time we were together, problem number 5. We may have even done problem number 5, I can't remember. We got a 140-degree angle, so my sketch is a little off, but that's okay. And the radius is 2, and I want to find this shaded area right here. So the area of the whole circle is pi r squared, and my radius was 2. So that would be 4 pi. The area of the whole circle is 4 pi. I am not interested in the whole circle. I am interested in only 140 degrees of it. So I want 140 of the 360 degrees. That is the fractional piece that's shaded. So 140 3/60ths of 4 pi. Oh, let's start reducing this a little bit. The zeros cancel. 2 goes into that. Let's see, that'd be 7/18 times 4 pi. That would be 28 pi over 18, or 14 pi over 9. And is there a unit on that? Inches? Yep, so that would be square inches. The radius was 2 inches, so your area is going to be in square inches. Perfect. Perfect, perfect. Okay, now we're going to write the equation. This is number 6. We're going to write the equation of the curve. So when we look at this, we have to figure out how we're going to start. It doesn't make any difference, but we need to decide, are we looking at this as a sine or a cosine? How are we looking at this thing? It's completely up to you. You're going to write 2 equations, 1 of each, so the order makes no difference whatsoever. And as we've discussed, these equations will have a lot in common. They'll have a lot in common, almost everything in common. So when I look at this, I think of the, because I drew it, when I drew it, I drew this right here, which is a sine. So the first thing I drew felt like a sine to me, so I'm going to start with that one. If I'm looking from black dot to black dot, that's one period of a sine curve. It's one hill and one valley. I'm starting at negative pi over 10. So this would have to be x plus pi over 10. My amplitude is 3, and I have drawn a positive sine curve, so I'm going to put a positive 3 there. This curve has no vertical shift. It hasn't been lifted up or down. It's still oscillating across the x-axis. The period is not 2 pi though, that's pretty clear. So there's a number here that has altered the period. To find that number, I need to remember how I find the period of a sine curve. The period of a sine curve is always 2 pi, unless there's a number here, because that number will always divide the period. So my period is 2 pi over that number. But looking at the graph, I can see that my curve is running from negative 1/10 to positive 3/10. Negative 1 to positive 3 is a distance of 4/10. Negative 1 to positive 3 is a distance of 4/10. So to solve for n, because n is the number that divided 2 pi to give me this period, I'm going to cross multiply. And it looks like that number must be 5. Now the good news is, if you see a cosine curve when you look at this, let's go from red dot to red dot. That would be a cosine curve. That curve still has a period of 2 pi over 5, 4 pi over 10. This number will never change. It is the same. That's the same curve. It has the same period no matter where you start and stop. It has the same amplitude. It has the same vertical shift. The only difference is if you're going red dot to red dot, you're not starting at negative pi over 10, you are starting at 0. So there is your cosine curve. Now we're going to solve a couple of equations. These will involve our calculators. So we'll solve a couple of equations. First one's in degrees. So I'll add 7 and divide by 3. And before I go to my calculator, I am going to stop and ask myself, where am I going to be looking for answers? Now my window of opportunity is the entire circle. So I need to figure out where I'm going to be looking for answers in degrees. So I'm going to set my calculator in degrees. Where am I going to be looking for answers in degrees if the tangent is a positive number? Well, certainly the tangent is positive in quadrant 1. Groupies, everything is positive in quadrant 1. Where else is the tangent positive? The tangent's positive in quadrant 3. Why is the tangent positive in quadrant 3? Because tangent, by definition, is y over x. And what do you know about quadrant 3? Y and x are both negative. So therefore, we would have a positive tangent in quadrant 3. Now, this certainly is not one of my special triangles, so I'll second tangent. Remember, that's how we find angles. We second tangent. So I will second tangent 17/3, and I get 79.99 degrees. So in the first quadrant, This is the first answer, that blue angle right there. That blue angle is indeed 79.99 degrees. In the third quadrant, that will be my red angle. In the third quadrant, that will be 180 plus 79.99, which is 259.99. So our blue angle and our red angle are the answers to that question. Okay, now we're going to solve another one. So we're going to do everything exactly the same, except this one has to be in radians. Now that is not going to change hardly anything, you guys. We're going to do this almost exactly the same way. Our window of opportunity is still the whole circle, this time in radians, but still 1 revolution. And we're going to look for places. Let's see, we want the cosine to equal, subtract 3 divided by 4, 1/4. So where can the cosine be a positive number? Well, cosine is positive in quadrant 1, of course, and in quadrant 4. Now, how do I know the cosine is positive in 4? Cosine, remember, is x over r. So cosine will be positive wherever x is positive, and x is positive over here. Now I need to know the angle. That is not one of my special triangles. So I'll set my calculator in radians, because that's what the directions said. And I will second cosine 1/4. And I get 1.318. Now the black angle is clearly going to be 1.318. You might be tempted to say the second angle is negative 1.318. And I can't argue with that, because that would be a way to name that angle. The problem is these are our directions, which means all of our answers have to be positive. They have to be bigger than 0. So negative 1.318, while it does name that angle, would not be appropriate in this case. Instead, we need to go all the way around to here. Now, how are we going to find that angle? Well, if I were in degrees, I would take 360 minus that, wouldn't I? But I'm not in degrees, I'm in radians, so I'm going to have to take 2 pi minus 1.318. 2 pi minus 1.318. And that will give me my second angle, which is 4.965. 4.965. Number 9. In which quadrant am I if the cosine is negative and the sine is negative? So this means the cosine is negative, and this means the sine is negative. So in which quadrant would you have both negative? Well, cosine is x. So x would be negative here and here. So for this qualification, we got to be in quadrant 3 or 4. Sine is y, and y is negative here and here. The only quadrant that meets both qualifications is quadrant 3. So the answer to that question is quadrant 3. That's pretty easy if you just think about it. Just think about it. Pretty easy. Find the exact value, that means no calculator, of the angle whose sine is negative root 3 over 2. The angle whose sine is negative root 3 over 2. Well, let's see. This is, remember, there's special rules for this notation. This is a right side function, it's a negative number. So my triangle has to be in quadrant 4. Remember, this notation always means one answer. One answer. I'm on the right side. If that's a positive number, I'm up here. If it's a negative number, I'm down here. The sign is negative root 3 over 2. So I label my triangle accordingly. And this angle is negative 60 degrees. The answer is negative 60. This is not one of those where you're going to go all the way around, because this area is off limits. You can't even pass through it. You have to name this angle between negative 90 and 90. The answer is negative 60. If you're confused by that, go back and look at your notes and the rules that are associated with this notation. Number 11, we're going to find the cosine of the angle whose tangent is 3/4. One more time. Find the cosine of the angle whose tangent is 3/4. So the first thing I do is figure out where this angle can be. Again, this notation is a right side function. That's a positive number, so I am in quadrant 1. The tangent is 3/4. The Pythagorean theorem would make this a 5. What do I want to know about that? It doesn't say find the angle. It says find the cosine of the angle. So the answer is 4/5. Next, what is the period of this big, long equation? Well, what's the period of the first piece? What's the period of this? Well, let's see. The period of that would be 2 pi divided by 1/2, which is 4 pi. That means that every 4 pi, that curve repeats. So it's going to repeat at 4 pi, 8 pi, 12, 16, 20, 24, 28. That's all I'm going to go for now. I can extend it longer if I need to. But every 4 pi, that curve repeats. What about this one? Its period is 2 pi divided by 2/3, which is 2 pi times 3/2, or 3 pi. So that curve repeats at 3 pi, 6 pi, 9 pi, and 12 pi. There's your answer. The answer to question number 12 is 12 pi. Now we have number 13, we have some word problems. Charles is perched at the top of a tree that's 32 feet tall. So here's the tree, 32 feet tall. His angle of depression to his pre-cal book, he's looking down here at the book. Here's the book, here's Charles. Looking down at the book, his angle of depression is 23 degrees. This angle is 23 degrees, which means this angle is 23 degrees. How far is Charles from the book? What function are we going to use? Well, it looks to me like we're going to use sine. So we'll say sine 23 equals 32 over x, opposite over hypotenuse. X sine 23 equals 32 if I times both sides by x. So x equals 32 over sine 23. Now on your quiz you stopped at this point, but now we got to actually type it in. Make sure you're in degrees. This is a degree problem. Make sure you're in degrees. So 32 divided by sine 23. He is 81.898 feet from the book. Now, we got a ship sailing. Here he goes. A ship sails from port on a course due west. So here's port, and here he goes due west at 4 knots. Remember, knots are miles per hour, nautical miles per hour. 6 hours later, all right, stop right there. 6 hours later, he's here. So he has traveled 24 nautical miles. He's gone 4 knots, 4 nautical miles per hour for 6 hours. He turns due south and sails for 2 more hours at a speed of 10 knots. So that, or no, I'm sorry, 2 more hours at a speed of 5 knots. So he's traveled 10 nautical miles. So this one's 24, this one's 10. West 24, down 10. At this point, what is his distance and direction from port? So here's the original port. Here he is now. The distance will be easy. He went from due west to due south, so that's clearly a right angle. So doing the Pythagorean theorem, this works out to be 26 nautical miles. That's how far he is from port. That's a Pythagorean triple. I happen to have it memorized. Now, what about his direction? Well, I really need this angle right here. I need that angle. So to find that angle, I'm going to call it x. To find that angle, I'll probably use tangent. I'll say the tangent of that angle equals 10 over 24. So then I'll go to my calculator and type in second tangent 10 over 24. (22.62 degrees). Now, do not say that his direction is 22.62 degrees, because remember, 22.62 would look like this. That's not where you want him to go. This is his direction. This angle right here, look, this angle right here is his direction. So if he went all the way to here, it would be 270. He's not going quite that far. So to get his direction, we'll simply take 270 minus 22.62, and we get 247.38. So his direction, measured from due north in a clockwise direction, is 247.38 degrees. Okay, now we are walking. Okay, so here's the building. And he is walking at a pace of 2.5 miles per hour toward the building. At one point, his angle of elevation is 54 degrees. After 30 minutes of walking, so he's still walking for 30 minutes, his angle of elevation is 62 degrees. So he's closer to the building, so his angle is bigger. How tall is the building? Well, we had one like this the other day, I think. We're going to need 2 equations for this problem. But before we can even set up 2 equations, well, I guess the first one we can set up, okay? If I call this distance right here y, I can say that the tangent of 62 equals x over y. Tangent equals opposite over adjacent. So for this right triangle, there's my equation. I got a problem here though, because this is minutes, and I need a distance. I need a length. I don't need a time, I need a length. So I got to think about this for a second. He's walking 2.5 miles an hour. That's miles in an hour. We're letting him walk for 30 minutes, which is half of an hour. So this distance would actually be 1¼ miles. Because if he can walk 2.5 miles in an hour, then he can walk 1¼ miles in a half an hour, 30 minutes. So my second equation will be tan 54 equals x over y plus 1.25. Now you have a system of equations and we have to figure out how we're going to solve it. So I think I'll take that top equation, x equals y tan 62, and I'm just going to plug that in here. So I'll have an equation that says tan 54, I'm using substitution, tan 54 equals y tan 62 over y plus 1.25. Now I need to solve this equation. It only has one variable, that's good news, but I need to solve it. So I'm going to multiply both sides by this right here. I'm going to bring this over to here. That is going to be a distributive situation. So I'm going to have y tan 54 plus 1.25 tan 54 equal to y tan 62. Now to solve this, I need to get all the y's on the same side. So I'm going to take this one and move it over here. So I'm going to have 1.25 tan 54 equal to y tan 62 minus y tan 54. I'm subtracting this over to this side so that my y's are on the same side. So 1.25 tan 54 equals y times tan 62 minus tan 54. So factoring out the y. Now I'll divide both sides by this parentheses. So I will have y equal to 1.25 tan 54 over tan 62 minus tan 54. And I'm going to type that into my calculator very, very carefully. We've discussed this on a couple of different occasions, that when you type in, and we are in degrees, when you type this in, you've got to have your denominator in parentheses, and you got to remember to close the parentheses that your calculator opens every time you hit tangent. So 1.25 tan 54 divided by parentheses tan 62 close parentheses minus tan 54 parentheses parentheses, and the answer is 3.411 miles. Now, be really, really careful, kids. That is not the answer to the question. That's why. That's how far he is from the building. We want to know how tall the building is. So we want x. X is y times the tangent of 62. So I'm going to take this number right here times tan 62. 6.416 miles. Okay, obviously Mrs. Ford made up this problem because the building would be 6 miles tall. That's a pretty tall building, but that's the answer that we came up with. All right, number D, or letter D. We're going to find the angle of depression of a goose. The goose is 50 feet above the ground. Here's the goose. And he needs to land at a pond that's 198 feet from the goose. Here's, goose is 50 feet above the ground. There's a pond over here that's 198 feet from the goose. We want to find the angle of depression. That would be this angle, or I will use that angle. The angle of elevation and the angle of depression are always the same. So I would prefer to use that one. Sine x equals 50 over 198. So x is the angle whose sine is 50, 198. Second sine, remember you're finding an angle. So second sine, 50 divided by 198. The answer is 14.627 degrees. 14.627 degrees. Okay, one more. It's a two-parter. Let's do the area part first, since we've already done one like that with area. We should be pretty good with the area, and then we'll do the arc length part, because the question is asking for both area and arc length. Now, area is going to be easy. The area of the whole circle is 16 pi. That's the area of the whole circle. So if we said, what's the area of the circle, you would say pi r squared, 16 pi. We don't want the whole circle, though. We want a piece of it. What fractional piece do we want? Be very, very careful. We do not want 105 3/60ths. No, no, no. We want 255 3/60ths. That's the fractional piece that we want, 255 3/60ths. Because the shaded part is the part I'm looking for. In this case, the shaded part has an angle of 255 degrees. That's 360 minus 105. Okay, now this is a calculator problem, so I'm going to feel free to use my calculator. So that's 255 times 16, so it's 4080. If I divide that number by 360, if I divide 4080 by 360, and then hit math and choose the fraction option, it reduces it for me. So it's 34 pi over 3. That would be the exact answer. If you wanted to go ahead and get a decimal, it would be 35.605. And the unit on that would be square centimeters. Either one of these answers would be fine. This is the exact answer, but it doesn't say find the exact answer. It just says find the answer, and you do have a calculator, so you can get the decimal if you want. Again, to reduce this fraction right here, I just typed it into my calculator and then hit math and chose the fraction option, which is the first option, and it reduced the fraction for me. Now I want the arc length. Now this time I do want the arc that's created by the 105. So I remember arc length equals radius times radians. I do know that my radius is 4. I have a problem though, because this is a degree measure. So over to the side, pi over 180 equals something over 105. So x equals 105 pi over 180, which again, I can reduce that by hand. And certainly, if the calculator is too confusing for you, reduce it by hand. Divide those by 5, do whatever you need to do. On the calculator, I would do 105 divided by 180, and then hit math, enter, and it gives me 7/12. So that reduces to 7/12. That is not the answer. That is the radian measure of the angle. So the arc length would be 28 pi over 12, or 7 pi over 3, or 7.33 if you're using and that would be centimeters, if you're using a decimal. That is the length of the arc. Radius times the radian measure of the angle. We had to find the radian measure of the angle. We plug that in. This answer are both completely fine. If it says exact, it would have to be this one. This, since it's in the calculator section, you could get a decimal, that would be the decimal. Okay, that's it for the pretest. Have a great day.